Hello, this is Devin Garner, and I'm in the Go programming language group with Vanessa Cooper for Dr. Eckert's Advanced Programming Languages class. And this is an implementation of the traveling salesman problem using the 2-opt algorithm. Let me first explain what the traveling salesman problem is. Basically, if you're given a list of cities and the distances between each of them, you need to find the shortest possible route that visits each city without repeating any city, and that returns to the original city in the end. So this is technically what's called an NP-hard problem, which means that as long as you have a small number of cities, then a computer can solve it quickly, but there's no known algorithm that can solve it quickly for a large map. And so there are algorithms that can take shortcuts to get a relatively good answer, but not guaranteed to be the best possible answer, that can do large maps in a short amount of time. But in order to get the guaranteed perfect answer, the only way people have been able to come up with so far is to try every possible combination. So I chose to use an algorithm which gets pretty good results, but it's not perfect, and it's called 2-opt. So first, let me run the program so you can see how it works. My test data is the capitals in the US. So when I run this, it's going to show the total number of miles is going to be 17,000 miles, and it's going to start in Alabama, go to Louisiana, Mississippi, and then end in Wyoming. And this is not guaranteed to be the best possible route, but it should be pretty close. So let's go through the code. I'm going to glaze over some of the things that we've already covered, but anything that's new I'll talk about in more depth. So first off, I'm using some structs to store my data. The city struct has the name of a city and its latitude and longitude, and a road contains two cities, so basically it's to travel from one city to the other, and the total distance to make that travel. So I have a utility function that will convert the latitude and longitude into miles, and I'll show you that code later. Next, I have an array of roads, which is a tour. That will be the data type for the final output of the program. And I have an atlas, which is a two-dimensional array of roads. So that will be used to show every possible combination of cities, what their distances are between each other, and that'll help with the calculation further on. So first I'm going to set up my test data, and I'm going to implicitly type this US capitals variable, and I'm going to instantiate an array of cities, and to set all the data I'm going to use curly braces and populate it with a list of cities, comma separated, and each city I'll do the same thing to populate each of its fields. So they'll just go in order. So Alabama Montgomery will go into the name field, and 32.3 will go into the latitude and longitude field, etc. So that will initialize my test data. Next, I'm going to use the make command. This is useful for dynamically allocated or sized arrays. So in my case, my test data could be any length, and I don't want to hard code for a certain length. So instead, I create an array that the memory size is based on a variable rather than hard coded. So I take the length of my test data, which is US capitals, and use that with the make function to initialize an atlas array. Although the data type here is atlas, it's actually a two-dimensional array of roads, because that's how we defined it up at the top. So I could have also here said bracket 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 road, and so that will create my first dimension, but none of the indices will have any data yet. So I'm going to need to loop over the numbers from 0 to 49, which is my number of capitals, and on each index I'm going to need to make the second dimension So technically, using make, you could do like a staggered array, but in my case, for the second dimension, I'm also going to create a dynamically sized array based on the length of capitals. So essentially, when this for loop is done, I'll have a two-dimensional array where each dimension is of length 50. And finally, the actual value for each combination of indices for the two dimensions will be the actual road that connects those two cities. So these two for loops will go through every combination of cities and show the distance between them. And this calculate haversine distance will convert the latitude and longitude to miles. So now that I have my atlas set up, I can actually solve the traveling salesman problem and print out the result. I have quite a few utility functions I'll go through quickly and then explain how the algorithm actually solves the problem. So convert city indices to tour. We'll take an array of integers and the atlas and turn it into a tour. I use this because I thought it would be easier to manipulate integer arrays rather than city arrays. And so if I think of each city as a number, so for example, Alabama is number 0 and Wyoming is number 49, then I can manipulate an integer array that corresponds to the city, and then when I'm all finished, then I can convert it back to a city. So the code here is pretty self-explanatory for how it does a conversion, so I'll skip over it. But one interesting thing we haven't gone over before is the panic method. That's similar to throwing an exception in a language like Java. There's also a recover function which can catch the exception, but it works differently because it's not scoped the same way that it would be in an exception-based language where you have a try-catch. And I'm not going to go into all the specifics of that, but panic is a way of basically throwing an error message which will probably kill the program, but it can be recovered. So another utility function I have is make ranged array, and that will take two numbers like 3 and 7 and convert it into an integer array that iterates over each number. So the result would be, in the case of 3 and 7, an array that goes from 3, 4, 5 up to 7. Next I have the function that actually solves the traveling salesman, and that uses the two-opt algorithm. The way the algorithm works is it takes a naive tour, which would just go from city 1, 2, 3, all the way up to 49, which may not be very short, and it'll take each inner tour and reverse it and see if that creates an improvement, and if so, it'll keep it as a new best tour and then keep trying to reverse inner tours. So for example, if I have the numbers 1 through 50, reversing the inner tour would mean taking the numbers 2 through 49 and putting them in reverse order. So it would go from 1 to 49 to 48 down to 2 and then back up to 50. If that creates an improvement, then it'll be stored as the next best tour, and then it'll try to do the same thing again, which would be keep 1, 49, and at the end 2 and 50, but it'll take the next inner part, which would be 3 to 48, and reverse those. And once it's gone through every combination of trying to reverse the inner route, whatever best distance it finds, that's what it'll keep. So to go over the code that does that, I'm going to use the utility function for make ranged array. That'll just go from 0 to the last index of my cities, and I'm going to convert that array into actual cities and call the calculate total distance function. I haven't gone over that utility function yet, but it simply enumerates all of the cities and adds up, all the roads that connects the cities and adds up the total distance. Next, I'm going to have a loop which, as long as an improvement is made, it will keep iterating. And so first, I'll set the improvement made to false inside my loop, and then I have two nested for loops that will go through each combination of inner routes that could be reversed. And then the two-opt swap method will actually take the two indices that I'm choosing to reverse, and it'll return back a new tour with the outer tour the same, but the inner tour reversed. Then I'll recalculate total distance on this new tour to see if it's better than the previous, and if so, I'll keep it as the new best. And then if I have a new best, so an improvement has been made, I'll break out of both of these for loops so that I'll start back over at the beginning, which will start over finding inner routes to reverse. So although this is complicated and seems like it might go through quite a few permutations of possible city combinations or road combinations, this will be much fewer permutations than checking every possible combination, because every possible combination would actually be the factorial of the number of cities, which gets very large very quickly. And this will be a much smaller number of routes to test. So the code that actually does the swap, it will take an array of indices and two indices to reverse. And again, this is just using integers. It's not using the actual city array, because afterwards it'll be converted into a city array. But I simply have three for loops. The first copies them in the same order. The middle one, when it copies them in the same order, it just goes up until the swap start. And then from swap start to swap end, it'll copy them in reverse order. And finally, it'll copy the end of the array in normal order again and return the result. The print tour method will output the total distance of the tour, and then it'll enumerate through the entire tour. And this range function is something we haven't gone over before. It's used in combination with for, and it'll enumerate over every element in the array. It actually returns two variables when you call the range function. The first is the index, and I don't need that in my case, so I'm just using an underscore to ignore it. The second variable it returns is your actual element of your array. So I'm going to enumerate over all the roads, and on each one I'm going to print out the two cities the road travels between, as well as the distance. So this print tour method will be used at the very end after I've found the best possible tour. The calculate total distance uses that same range method, and it will enumerate over the whole thing, aggregating the distance in miles to get the total sum. Finally, the calculate haversine distance, I can't exactly explain how it works because I don't understand the math behind it, but it uses trigonometry with sine, arctangent, cosine, and square roots, as well as some exponents, to convert latitude and longitude into miles. And it also does conversion between degrees and radians. So the code I did actually write, but the actual math behind it, I just found an equation online and converted it to code. So it seems to work, but I couldn't tell you the exact trigonometry behind how it works. So going back to our main method at the top, then after we've converted our test data into an atlas, we simply call solve traveling salesman problem and then print out the tour, and our program's done.